Imagine a world where technology doesn't just wait for our commands, but actively accompanies us, easing our physical burdens in real time. Today, my team and I are excited to present our project, the Human Following Detection Robot. In our rapidly advancing world, the need for autonomous assistance is growing. Whether it's a shopper struggling with heavy bags, a nurse delivering medicine in a busy hospital, or a soldier carrying equipment across difficult terrain, the physical strain of transporting goods is a universal challenge. Traditional trolleys require manual effort, and remote-controlled robots require constant human attention. Our goal was to bridge this gap by creating a robot that coexists and interacts with humans seamlessly. We wanted to build a machine that doesn't just move, but perceives its leader and follows them autonomously, maintaining a safe distance while navigating obstacles. The heart of our robot is the Arduino Uno microcontroller, which acts as the brain. To give our robot senses, we utilized a combination of ultrasonic and infrared (IR) sensors. The detection phase. The ultrasonic sensor works by emitting high-frequency sound waves. When these waves hit a person, they bounce back. By measuring the time of flight of these waves, the robot calculates exactly how far away the person is. The following logic, we programmed a specific Goldilocks zone. If the person is further than 20 centimeters but closer than 50 centimeters, the robot moves forward. If the person moves too close, the robot stops to avoid a collision. Directional tracking. By using two IR sensors placed on the left and right, the robot can detect if the human has turned. If the right sensor detects a reflection while the left doesn't, the Arduino instructs the L293D Motor Driver to rotate the right wheels, allowing the robot to follow the person around corners.